Hello class, welcome to the week 4 tool demo for DFS 540. As we step into advanced dynamic analysis, this week we start talking about debugging packed executables. You know, sometimes it's difficult to dump a process, to actually fully, completely dump a process. It takes a lot of time, it can be difficult. Sometimes you might dump the process but actually end up with just a file that just won't run. So what do? Well, we're going to look at this technique called debugging for dealing with packed executables. So in this case, we're going to examine the process in memory without even attempting to actually dump it. So debuggers, they enable us to examine the code of the running process even if the file that began executing was packed. So this approach to dealing with packed malware involves allowing the packed program to actually run and unpack itself into memory. So this week, as you go through your readings, you'll become familiar with at least two debuggers, one of which is Ladybug. So we're going to use Ladybug actually in this tool demo to examine the unpacked code directly in memory instead of analyzing it from a file that is stored on the disk. Okay, so we'll go ahead and get started by first opening up on our tools menu our Ladybug. So in our DFS 540 VM, we'll go to the tools section or the tools folder on the desktop, and you'll see ODBG 201. So this is version 2 of Ladybug. Double click, and we'll scroll down until we see the nice little splattered looking bug, Ladybug. So we'll open that up. Actually, let me back up and do one thing here. Just go ahead and right click and actually run that as administrator, so you don't have any issues that come up with that. If you do get prompted for a question about analyzing compressed code, you shouldn't with this particular version on your VM. Just go ahead and select no for that. Okay, so I'm going to go out and open up my my sample here, my packed program Evilicious. So I have a folder on my desktop labeled Evil. Again, this is just for demonstration purposes. You'll have a different sample for your particular lab this week. So I'll bring that in, and it starts to go to work. Okay, and so I'm actually loading the packed executable into Ladybug and actually running this specimen here. Now, just to give you an update and a little bit of insight of actually what's going on here, when we look at bringing this particular executable in, we are actually not seeing the interesting code yet because technically it is still packed. Okay, so if you look at the bottom right, if you will, of your screen, if you're following along here in Ladybug, you'll actually see where it says paused. Okay, so I need to run the Evilicious executable so the specimen can actually unpack itself into memory. And how do I do that? Well, I just press F9 and just watch in the lower right hand corner. You'll see that change from paused to run. Okay, now the next thing that I want to do is actually start the examination process. Okay, so I've loaded the packed executable into Ladybug. Okay, I've ran the specimen. Now I want to examine what is called the memory map, okay, to actually spot sections that might contain unpacked code. Okay, the way I bring up the memory map is at the same time pressing Alt and the letter M as in Mike, and this brings up my memory map. Okay, now the memory map in Ladybug displays the memory sections that are allocated to the process that you're debugging. Now, one or sometimes more of those sections should contain the actual unpacked code. Unfortunately, though, finding the right section can actually be time consuming because you might be uncertain where to look. Now, a few pointers for you. A good starting point might be the section that's directly associated with your executable. Okay, so in this case, Evilicious. Okay, so looking in the owner column, I see Evilicious here, okay, and I also may want to, as a second point, examine other memory sections, paying really close attention to the access, okay, to the labels where it says RWE, okay. So read, write, execute, okay. So in this particular instance, this is what I'm looking for as some standouts. Again, the owner and then these accesses. Now, going back to what we've covered already in this course regarding our static analysis, another way that you could find the section that contains the unpacked code would actually be going back to previous sections of the course where you might have dumped the program from memory to examine it and brought it into IDA Pro, okay? And that could have provided you with the offsets that were interesting instructions were, okay? And then you could have actually looked for those offsets in the memory map here inside of Ladybug, paying attention to the starting addresses for the memory sections. But at this point where we are, again, the two good pointers, looking at the owner section, the owner column, and then your access for read, write, execute. Okay. Now in this particular instance here, I see UPX 0, UPX 1 under the section. Okay. And this is a good starting point for me. Now to look inside of this section, all I have to do is actually right click on it and then view in CPU disassembler. Okay. Now if the addresses that were assigned to you in the sections of your lab are different, it's because you have a different sample. Okay, so again, just to reiterate, this is just a sample. This is not the actual malware sample that you're going to be using or executable that you're going to be using in your lab. This is just for functionality to walk you through the different features of Ladybug. Now, what you want to do now is actually press Control A, okay? And what that does is it asks Ladybug to reanalyze the section so you can spot code and data. Okay, and then you'll start scrolling through the disassembled instructions. Now, you're probably on the wrong track if you see a lot of unusual, rare instructions. Okay, you're probably in the right neighborhood if you see a lot of common assembly instructions, and these look pretty common here: move file, copy file, get system directories, things like that. You'll notice possibly some interesting strings or API calls, and I think we're already starting to see some of those here. Destroying key, crypt, destroy key, destroy hash. Okay, so just something to keep in mind. Does this look familiar to you? Not saying you're not going to see some that maybe look out of place, which could be indicators for you, but for the majority of what you're seeing, once you go into the disassembler mode, are you seeing some familiar territory? Okay. Now, a convenient way to further validate that you're looking at legitimate code is really just asking Ladybug to do some work for you. You can say, hey, extract all intermodular calls, okay, and that's going to locate all the calls in that particular memory segment. So all I'm doing is right click, search for all intermodular calls. Okay. And this brings up a little bit of an easier view for you, looking at all the calls for this particular executable. Now what you'll do at this point is you can scroll down to locate some of those calls that actually might be interesting. Okay, and this is the left hand column here just next to address. Okay, and Ladybug presents you with a window showing those intermodular calls separately, and you can start going through and looking at them. For this particular example, I start seeing quite a few call dword PTR. So we're going back to this crypt decrypt. So we see this call to crypt decrypt that we saw earlier. Okay, so I'm just going to scroll through and see if that pops up again, because it already caught my attention already in the previous screen for this crypt decrypt. So I'm going to go through and actually see if that stands out to me here in the destination name. And here I do see the crypt create hash, crypt hash data, so we're in the right neighborhood. I see the crypt encrypt. Okay. Crypt destroy hash, destroy key. And here's a crypt decrypt here as well. Okay, so this looks to be something of interest. Okay, a program, a destination, particularly for decrypting. Okay, that stands out. Now, in this particular section, I can actually examine the contents of that selected section. Okay. Now, for this particular area, scrolling down, looking at this, looking solely at the disassembler instruction at this address that is 2Charlie93. Okay, if I was looking solely at the disassembler instruction, I wouldn't actually see the name of the crypt decrypt call. Instead, I'd see a call to the function whose address is expected to be stored, okay, at the 100.1034 in the previous screen. However, if I click that line, Ladybug shows that the function is called crypt decrypt. Okay. Now, if I want to set a breakpoint for further analysis, okay, so this stands out to me, so I can now examine and interact with the code, even though the program we began debugging was packed from the beginning. Okay, so if I want to decrypt contents, okay, of a temp file, I could set a breakpoint after this particular call here. Okay, and all I have to do is actually to set that breakpoint is set what's called the test instruction. Okay, so go back, follow this in the disassembler. Okay, and there's my test EAX. Okay, so from there, to set that breakpoint, I will actually select the test instruction. Okay, right click the line and select breakpoint. And then hardware. And then click OK. And you'll see that I have now set a breakpoint there. So Ladybug does enable you to set your traditional toggles, your software breakpoints, but it's confused by the packed nature of this particular executable, and it would actually disable your breakpoint when you restarted the process. So when you do a hardware breakpoint, this works very well here. Remember, hardware breakpoints, and you'll recall this from the lecture, utilize breakpoint capabilities of the CPU, and they tend to be more reliable than software breakpoints. So here, after you've set the hardware breakpoint after the crypt decrypt, and then Control F2 is the other way that you can actually do that. Okay, and it says the debug process is still active. Would you like to close it? Okay. That's at that point we're actually going to hit no because it's still debugging. Okay, and then we want to go ahead and make sure that it is running, which it is. Okay, and what we can actually do in this particular case, just for the purposes of demonstration, I'm just going to hit yes. Okay, and just to show you once again, hitting the F9. Okay, so F9 to make sure it's running. Okay, and you can see by doing that the breakpoint is still there. Okay, so we didn't lose anything there. It gives you the opportunity to go back and see the contents there. So that's just a little bit of an overview for you for Ladybug. There's a lot of good literature, open source documentation. Also, you have the cheat sheet that is available as well, that will be available in this module for you to look at. Just keeping in mind with Ladybug, you're able to use the process memory map to examine the contents of the sections to find the unpacked code. You can disassemble contents of sections and analyze them, and this really gives you a good opportunity to interact with the specimen within the debugger. So we're going to use these techniques as building blocks as we continue forward in our malware analysis, specifically for this week for our advanced dynamic analysis section.